Hi, my name is Eric, and in this tutorial I'm going to show you the different ways of loading 3D models into your FMX application using Gorilla 3D. We're going to start with a multi-device application and choosing the blank application. First, we need a viewport. But take care, no longer use the T-Viewport 3D from standard FMX because it's not compatible with Gorilla 3D. Instead, we're using the T-Gorilla viewport. Our scene also needs a light, otherwise we won't see anything. Here you can choose from the standard FMX T light or from the T Gorilla light. And in our demo, I will change the light type to point light and move it a little bit upwards. Alright, let's save our project. Gorilla 3D is able to load 3D models at design and runtime. And we support loading from file, zip archive, so-called package, or from the embedded binary data of your formula. We provide many popular and widespread formats like FBX, Collada, GLTF, OBJ, STL, and many more. When loading from those file formats, Gorilla 3D is unifying the different structures in the files to a uniform abstract data structure. It automatically loads materials and textures, vertex groups, and different kinds of animations. Let's start with the first and easiest way to add 3D models to your form. This is done by adding a T-Gorilla model to our viewport. Heading down to the source property and select your file. I have prepared an animated character from mixermode.com. In our loading options dialog, we can choose if we want to import embedded animations, if we want to compress or cache animations afterwards, if we have any separated animation files for Collada or FBX format, if we want to import lights or cameras. In our case, I don't want lights and cameras. Because we're loading our model at design time, we're using the memory of Delphi. So loading textures, materials, animations might exceed memory very fast. So it's recommended to scale down the textures at design time. The model was imported, but you can see it because it's very large, so let's scale it a little bit down. And as you can see, it's flipped upside down, so let's rotate it on the x-axis. Let's save it and start. As you can see, the loading process works fine. When loading model data by using the source property, all the model data, including textures, materials, animations, and more, is getting stored as binary data in our formula. So when we're having a look in our project, we will see our FMX file is around about 18 megabytes. It contains all the binary data of your model, and you don't have to roll out the original model. It's all included inside of the formula data. Another way of loading 3D model data at design time is using the Assets Package Manager. So let's set one up. But first, let's clear our model by clearing the path. So everything is cleared, and let's add the Assets Manager. The Gorilla Assets Manager is able to handle multiple packages. And the package itself is a zip archive with a specified structure readable by Gorilla 3D. But you can open up with any zip manager you know. So at first we have to add a new package. I will call it My Package. Packages can be used in memory, then we will leave the file name empty. But in our demonstration, we will use it as a physical file at ctemp myPackage zip. In the next step, I will add the model data inside of the package and not directly in the model. So let's open up the package with the editor tool. We're going to choose My Package, and we're going to add our previously used character file. And because we're still in the IDE at design time, we're using the memory of Delphi, we're going to limit the texture size. As previously, we're not importing lights or cameras. All right, everything is loaded. We can have a package view. And you will see the character is inside of the package and it is not inside of the FMX. All right, let's store our project. Now we're going to link the assets package to our model to load it from there. Simply link the assets manager in the model and set up the package. We called it My Package. And to link it to the specific model inside of the package, we put in there the file name. And done. The model is there. And it's not getting stored inside of the FMX. It's always loaded from the package itself. So let's have a look at the package stored under ctemp. All right, let's have a test and start our application. Great. A third way to import model data at design time is to use the asset store of Gorilla 3D or the Sketchpad plugin. So to do this, at first we're going to clean up our scene by removing our model and by removing our assets manager. In the next step, we're going to add the prefab system, which allows us to open up the asset stores. Here, we click right on the component and we choose Asset Store. In our Gorilla 3D Asset Store, we have some optimized models for you prepared to directly load and embed into your formula. All the model data getting imported inside of the FMX file and are not accessible by a separated file. So have a look at the cowboy. We try to embed this. You will receive the author's attribution info directly copied to your clipboard so you can paste it anywhere. Simply rotate it and let's move it a little bit down. Good. Open up the viewport editor to scroll out. All right. I guess the light is a little bit inside of the character. Perfect. All right. There we are. Having a cowboy character. We also offer a Sketchpad plugin, also accessible at the prefab system. So right-click and choose Import from Sketchpad, and the embedded browser for Sketchpad search will pop up. Here we can search for keywords or for directly UID access of a specific model at Sketchfab. So I'm looking for ship. Let's take this one. Yes, I'd like to embed the model. When working with Sketchfab, you will need your own account to access download. So I already have an account, so I can accept. When the download is finished, an author attribution will pop up again. and all the information getting copied to your clipboard. You now see the model, and it's quite large again, so let's scale it down. And let's flip it. All right, looking good. And let's start again. Like mentioned before, the Gorilla Asset Store and the Sketchpad plugin will save model data and textures inside of the FMX file. So here we can see our model data is completely in the FMX file and getting rollout with your compiled application. So far for design time usage, and now we're explaining how to use model data at runtime. But at first, let's clear up the scene again. You might ask, why should I care about loading models at runtime? But as you may recognize already, loading at design time comes with some limitations due to the memory size of the IDE. Loading at runtime gives you more power to your assets and allows you to load models with the full quality of the asset, full texture size, and at a state of your application when you like. Because when loading at design time or setting up at design time, everything is getting loaded when the form is created. So we start with a simple example. Just go to the formula, select the events, on show event, and here we want to load our model. So set up a variable. We're using the tGorilla model class and the class function load new model from file. We will need an owner component in our test, so let's say it's the Gorilla viewport. We do not have any packages yet, so we just say nil. We will need a file path, get into that right now. And the last parameter are the animation caching flags. In our example, we leave that one empty because we don't want caching right now. So go to our assets. Here we have the path and the file name. Besides the owner component, we have to set a parent for our model. In that case, it's the same, it's the viewport. All right, so let's start. The application throws an error and it says the model format is not supported. So the difference to design time usage is at design time, we know all the formats, but at runtime, you can decide which formats are supported and which are getting compiled into your application. So to solve the problem, simply add the loader to our uses, and for each available format, we have a separated loader. For FBX, it's Gorilla FBX loader. All right, no exception. But like in the design time example, you don't see anything because the model is very large. We have to scale it down. So simply go to the scale property and set point size to. And as we remember, we have to flip the model too. So model, rotation angle, we rotate it on the x-axis. And let's start. There it is, our model loaded at runtime. We can go a step further on running the embedded animation. So animations are accessible by the animation manager inside of each model. And the animation for Mixamo, the default first animation is called mixamo.com. So we say play animation mixamo.com. And the animation works. Looking good. We can now expand our demo by using an assets package. And as you remember from the design time example, we already set up a package from there. So at runtime, we have to create our assets manager and a package and link it to the model. So let's start with the assets manager. You simply put it on a form. And let's create a package. Now, assets manager add empty package, and we call it, of course, my package, like before. And we say our package load from file ctemp my package zip. So now we have a loaded package we can link to the model, and it's going to load it from there now instead of directly from the file. And as you can see, it has been loaded. It's now coming from the package instead of the file directly. Okay. This way of loading at runtime is the fastest one, but we're missing all the options from the options dialog at design time. So let's see how we can modify the loading process at runtime. This is done by alternatives for the already known function, like load new model from file. We're going to add another local variable, call it lopt. We're going to use the structure tGorilla load options. Wow, this is not known yet because it's another unit, Gorilla dev types. Okay, so here we can put our file name into. It's the first parameter path or UID. As second parameter, we're putting our package into. And the rest is optional. All right. In our test case, we're going to set a texture limit. So use the structure lopt, get to texture limit, and we're changing this to, let's say, 128, quite small. Now we have the structure, we can replace the complete parameter list. Oh, I'm sorry, just point. And of course, I've deleted the order. we go. All right, that worked. By this structure, we can also activate animation caching. So let's do this for our test model. Go to caching, and there's a global constant available for a very easy setup. Gorilla animation, right, caching, default. And it works. So when using the caching, Gorilla 3D outputs a message for you at debug time. So here we see caching to animation in around about 1 second. And the default caching will only cache the animated vertex positions. The rest will be static in the GPU. As we already know from the design time dialog, we are able to control the input of lights, cameras, and embedded animations. And in case you have further separated animation files, especially for FBX or Collada format, simply call the add animation function with the full file name, and it will be automatically integrated in the loading process. Further on, we can add a callback function called onStatus, which is getting called during the loading process. And we can explicitly reuse an asset of a linked package. At the beginning of the tutorial, I said that Gorilla 3D is unifying all the different formats into a uniform abstract data structure. These are the so-called definition objects, or in short, def objects. While the T-Gorilla model is a visual representation for rendering, the def objects are the logical background. So, let's modify our test case to only load up a definition object, and to then reuse it in multiple models as visual representation. At first, we're going to add a new unit called Gorilla Loader. And by using the T-Gorilla Loader class and calling the load undefined model def from file with our options, we are able to receive a new def object. After we've loaded this, we only have to apply it to a model. So let's remove this line here and say model, T-Gorilla model, create Gorilla viewport. Now we can load from the definition, LDEF, and because we know it's a model, we can cast it to the model def. Okay. Great. Looks like before, but now we are loading from the definition directly. And a great advantage is that we now can reuse the def by creating another model. So we're creating a second variable. Also put it on the form, but let's modify Copy that port. Let's modify the position a little bit. And yeah, let's move a little bit in depth. So, and what I was missing is I have to load from definition. Okay, and now you see two instances of our model. Both are reusing the definition and also reusing the vertices. This process is called duplication, and it's different from the proxy rendering you might know, because each instance can play another animation, or we can modify the materials for rendering. But for now, we're not going deeper into the topic of cloning, duplication, or instancing. This is worth another tutorial. Finally, let's see if the animation also works on the second model. Simply call L-model animation manager, and we're applying the same animation because the model only has one animation. Maximo.cam. Let's run it. All right, the animations are working. Difficulties with the logical and visual structure arise as soon as one of the sides is modified. The other view is not implicitly adjusted as well. This means that if I change the rotation of the gorilla model, it does not change the definition implicitly. Another problem is memory usage. It is definitely still a weakness of Gorilla 3D that we're working on. This affects several cases, but especially textures and vertex data. Textures are currently stored multiple times in memory, so they exist in the definition and the material of the model and also in the GPU itself. The basic T-bitmap structure in particular poses a problem here, as the image data is kept uncompressed, although it is a great component to easily edit image data. Vertex data is also available multiple times if static meshing has not been activated for the model. Static meshes are a great feature of dev objects. It allows to store vertex data partially or completely in a mesh buffer on the GPU. This in turn enables extremely fast rendering, also from objects with a lot of vertices. While standard FMX sends the vertex data frame by frame to the graphics card, mesh buffers allow ultra-fast rendering because the vertex data is already present in the GPU. So let's have a try on this one. I've prepared a model from Sketchfab again, and it's a quite a large model with around about 260,000 vertices using the GLTF GLB format. And let's import it in our project. And we say a local variable L city T-gorilla model, and we're loading from file directly in that case into our viewport. We have no package, and we are not using any caching, so let's copy the file path. And the file name. Okay, and like above, we have to set the parent gorilla viewport 1 And I know the model is quite large, so let's scale it down. No 0.1 seems to be fine. And the model is flipped on the x-axis. Like we're using the FBX format here, we also have to add a loader for our GLB format. So simply add Gorilla GLB loader. Okay. Now we're going to activate static meshing. This is simply done by setting the isStatic property to true. And all the submeshes contained in the model container will be set to a static meshing process. Because our scene now contains a lot of vertices, a lot of textures at a high resolution, we shall switch the project target to 64-bit, otherwise our memory gets exceeded. So let's start it. All right. And switching to 4K, we're still running on 60 FPS. 2 animated characters, high poly, and a very large scene with, like I said, around about 260,000 vertices. Looking good, fluently. All right. So we have reached the end of the tutorial, and I hope you could get some helpful information from here. Feel free to visit our documentation website, docs.gorilla3d.de, and see you soon. Bye.